Good afternoon, Jan.
Michael.
How do you do, sir?
Michael. Nice to see you again.
Nice to see you too.
Yeah.
Oh, goodness.
Let's let's see. So
Okay.
what I did, we had last time save and load bookmarks that we had last time. That was working. We didn't change anything. Then we had the save and load MRU. This one I just added, or we added at this null test, but it failed.
Mm-hmm.
So now if we save and load MRU, if we run that one, that passes. And then, so if you give an unknown specification hash,
Mm-hmm.
it doesn't find anything. It returns just null for the MRU. Okay, so
Okay.
this
Yeah.
hash doesn't exist in the database.
Mm-hmm.
So it returns null. And then MRU should reflect the UTC.
Mm-hmm.
So in previous cases, I'm just giving a local timestamp. Now let's try to give it a Zulu timestamp. So this is just going to be and to be sure of that, let's add another one. So now C1 C1 dot kind, was it that one?
Yeah, you've got 2 dots there right now.
Dot kind, and that should be UTC probably.
Okay.
Yeah, so because I added a Z here,
Mm-hmm.
when I parse it, it will consider that as a UTC format. That's this one.
Yeah.
And then, so when I give that one, when I store that one, what he returns is still a local feed. He
Okay.
returns everything local. That's what we wanted, correct?
I think we. Yeah, we want it to be UTC on the return as well.
You want it to be UTC on the return?
Yeah, let me think.
It's stored as UTC now.
Yeah, and I think I think we want UTC on the return. I would have to look at the code that's doing the comparison, but I think I do all the comparisons in UTC.
Okay, then.
Although it might not even matter, but yeah, I think UTC would be the better choice there.
Right. So then, and when we give a date, do we automatically take it as UTC or we convert it to UTC? I mean, if we give it with a Z, we say it's UTC, and when we give it in this format, we say it's a local date.
I think we give it in UTC as well.
Well, whatever. In fact, in the datetime, that kind of property, then we don't care about it.
Yeah, let me take a quick look at the code that's doing that. Let's see, that wouldn't be the network manager. That would, I think, be the fact manager. And So we are doing the get MRU, set MRU. So this is all in service of if the MRU date's not there. Oh, wait a minute. Yeah, so get MRU is not doing a comparison. I wonder if that's a if that's just not completely implemented. But then set MRU is setting UTC. Yeah, so it's UTC going in.
It's UTC going in and UTC coming out then.
Yes.
So if we go to the store test, let's see, then we are gonna adapt this immediately. So that means so whatever I give in, it should be considered as UTC.
Yes.
Okay. And what I get out then should be exactly the same. Yeah, so
yes.
This should still be the test. Here I give in a UTC time, and that what I get back should be exactly the same time then.
Yeah. So after you added that new assertion, can you run that that unit test again? I just want to make sure that datetime parse with Zulu is actually giving you back datetime kind UTC. I
would expect that.
Yeah.
Well,
yeah, but that's an assumption that we're making, so I'd like to validate the assumption. Okay, interesting.
Expected to be datetime UTC, but found local, and it goes over the now. So
interesting.
no.
So is there a parse UTC, perhaps?
What you could do is parse, and then you could set. Do you see the different formats? I don't think so.
No, that doesn't show up.
No. Wait, let me go to this one, this routine. No, come on, he goes to that one. Where was it implemented? It is implemented in the SQLite store somewhere. Load roll, save bookmark. Here. You have try parse or parse, it's gonna be the same. But so you have a datetime styles, which can be assume universal, assume local.
Okay.
Or if there is nothing set, but if there is a Z behind it, normally, because at a certain moment I try to save it in the database with a Z behind it. And then there was no need, I could just say datetime styles, none.
Mm.
And if I don't put the Z, then I get trouble because then he didn't convert it to local anymore unless I say assume universal. So he assumes that what he is trying to parse is universal.
Hmm.
And that's
Okay.
why I'm surprised in this store test. So parcel, what is he? A provider or still a provider? It jumps away.
So that doesn't take the datetime style?
Yes, it does. So I can say
Okay.
here, provider null and datetime styles. Here, what are the possibilities? Do you see
No, it doesn't
this?
show that.
No. So you have none, you have assume universal, adjust to universal. Yeah, assume local. Yeah, adjust to universal, but there is no. If I would do that, adjust to universal now. If we run it now, it should be okay.
Mm-hmm. Okay.
Okay, so now. All right, but so now he's getting further to be that, and he found that.
Yeah, so it looks like it adjusted it to local. Yeah, because now you're parsing it. It's UTC, and then yeah. So you're parsing it, you're storing it, and then you're checking its UTC, and you're comparing it with what you retrieved.
Right.
And
let me check. Let me check my database here. So the hash was the C hash. It stores 1839. Yeah. So it stores it as
okay.
UTC.
Okay.
Then,
So now when we get your date, if we read it out as UTC, then the that comparison that's failing right now should work, and then we can change that last assertion to be that it should be UTC. All of that should work.
yeah, but he shouldn't know. He shouldn't know. Because, look, when I...
Yeah. So why is assume universal returning a local date time?
Because when I save it, I set it to universal time.
Mm-hmm.
So that goes and look for that flag. Is it UTC or is it local? And dependent on that one, it changes. Actually, it just takes the ticks. Yeah, because the date time is always stored as UTC in the form of ticks.
Okay.
And the local or the UTC flag just tells you how it will be displayed. But so this to universal time just takes the ticks and it's converting it to this string. That's the way it is saved in the database.
Yeah, so we saw that it was saved correctly.
It was saved correctly.
So then
and then when I read it, I do a try parse exact with that format, and he assumes it is universal. What is in the database?
Yeah, but what we're seeing is that it comes out as local, or it's converted to local.
Yeah, it converts it to local. that's what I wanted to do.
Ah,
Yeah. So I want to have it back to local, but so why?
yeah. I think actually we want to change that. We want it to keep it as UTC on the way out as well.
Yeah, but expected. Okay, so this comparison here.
Yeah. So it's comparing with a UTC date.
Okay, it's not just comparing the ticks. It's
Right. Yeah.
taking into account. Yeah. Okay. All right. Now I understand why it fails. But then, yeah, and before I was assuming that the Z was making it UTC, which was not, and does it pass the test? So I was assuming two things which were wrong and which compensated each other to
Made him
make the
right.
test pass. Okay. Welcome to test-driven design.
Yep, indeed. So yeah, I think
So
yeah, right there
what we
after
want,
the try-parse, before the
yeah,
return, you can convert it to universal.
yeah, I can do that to universal time. Tac, tac. So here has to return UTC. So next time, and this one accepts UTC or and local time. Okay, so now now this one is UTC time.
Mm-hmm.
Let's try that again. That's UTC. Now they should compare. And now it's not going to be local anymore.
Right.
This is
Yes.
going to be UTC.
Mm-hmm.
You really have to test for everything. Yeah, now it passes.
Okay.
Oh,
Very nice. It's actually readable like that too. So the
is it
setting,
readable when it's
yeah,
okay?
yeah,
Then
that
make it
setting
big.
is an improvement.
Okay, it's all over my screen. That's easier.
Yeah.
Okay, so git. So what did we change here? Yeah, the comments, that one and that one. That's okay. And the store test, we adapted this thing. Okay. So correction for what we will call it get MRU must return UTC. Must always return UTC. Okay, that's fine. Let's. Where is my window here? Oh. That open my folder. Then go to command prompt. Push. Okay. So it is up to date now with my local repository.
Mm-hmm.
All right, let me show you that. Stop streaming and stream the other one here. So, yeah, it's here. So your main is here. I merged, added save and load bookmarks.
Uh-huh.
I merged that into with your main, and I added this one. But I only pushed it to my my GitHub repository for the moment.
Okay. Yeah, if you, let's see, I think what I would like to do is to rather than push main to the repository, push the branch. Let's see, what was your branch name?
Main, I
Remote
was
tracking.
working on main.
Wait, wait, no. Oh, okay. Okay, yeah,
no,
that's
I was working directly on the main,
okay.
which I shouldn't do, but
Yeah, so if you were to create a branch right now, then I think that would have the desired effect. Let's see. We might actually want to create the branch before the merge. So yeah, if you right-click, you can do all this in GitK. You can right-click on added save and load bookmark and MRU, so the third line.
this one.
Yeah.
Yeah, but this was the
Okay.
last one.
Yeah.
Huh? This was the last one.
Yeah. Yeah. I think we can cherry pick that into this branch. So yeah, if you first right click on that third line, then you can create a branch there, and then you can right click on the top line and cherry pick, and it will it'll set things up properly.
Create new branch.
Yes.
What's the name gonna be? Bookmark MRU.
Yep, that makes sense.
Bookmark MRU, like this.
Yep.
Okay.
And now you can let's see. It looks like it's yeah. So right click on that and see if you can do a checkout bookmark MRU.
Check this one out.
Perfect.
Yeah.
And now right click on the top line and select cherry pick. And it will cherry pick that into bookmark MRU.
That the top line.
Mm-hmm.
That's origin, huh? That's not upstream. Upstream is your side.
Yeah, but we want that that commit. So the thing that you just did with the MRU always return UTC, we want that change to be on bookmark MRU. So that change also happens to be in your remote, but that part doesn't matter.
Okay, you want that to be on the bookmark MRU, and then you can.
Yeah, and then you can push bookmark MRU to the Janaga repository, and we can make a pull request out of it.
Okay, yeah, I see. So here, cherry pick this commit.
Yep, perfect.
So now, okay, and now I can push this one.
Yep, you want to push that one to upstream.
Push it here. Yeah, right. Can I push it here? No, I'll just do it. So git push. Right. Git status yeah, I'm on bookmark MIU, git push / upstream, I think.
I don't think there's a / I think it's just git push upstream bookmark MRU.
-MIU. Fatal cannot be resolved to branch. Bookmark MIU cannot be. Oh no, bookmark with a capital. Isn't that? Yes. Okay, to jinaga.net.
Yep.
All right. If we go and check now, wait. File reload. Yeah, remote upstream bookmark MIU.
Excellent.
Okay. And if I do a git push origin, then it should be. Has no upstream branch. The current branch bookmark has no upstream. To push the current branch and set the remote.
Yeah, what we can do. So for origin, which is your fork of the code. So you've got main is beyond what the main will be in the Janaga.net repository. So one will have to rewind main so that you can get things lined back up on that. But then two, if you want bookmark MRU to be in your repository, then you'll have to do the full specification. So git push origin bookmark MRU. Because right now it's not set up as a tracking branch.
Yeah. Push origin. Okay, that seems to be working. If I go back.
So we should see two remotes.
Jinaga.net. Okay, we do here a file reload. Yeah, so that's correct here.
Mm-hmm.
The only problem is this main.
Yep.
So the origin main, which should go back to this one.
Yep. Yep. So we can fix that. So first you want to check out main. So you can do that within git k or at the command line.
Can I do it in git k?
Yeah, I think it's just a double click or check it. Yeah. And
okay.
then you can just right click on the upstream main. And then it should be a reset.
No, there's no reset here.
Well, that's something we can do from the command line. So that'll be a git reset -- hard to upstream / main.
It's status origin main. So git reset -- hard. And then I go to
upstream / main. Yeah.
/main. Origin main. Yeah. Okay, head is now at so that should be status. Okay, so if we do a reload here.
Okay. Yeah.
So
the remote is still pointing at that, but now your local main is in line with the Janaga.net main.
Yeah. Okay. And how do I get then? I just have to.
You can do that with a force push. Mm-hmm.
So git push dash force. Was it that?
Yes.
Force, and it will automatically push the current branch only to my
Yes.
repository.
Yes, and if you wanted to be certain about that, then you could actually say origin/main at the end.
We will see.
Yeah.
We will see. But
Yeah, there are two reasons that I trust this is going to work right.
bookmark, yeah, so that's all right. And the mains are back in sync again.
Very good. Yeah. So then when we merge, well, now you can go to the Janaga.net repository in GitHub and create a PR for it. And then when we merge the PR in, then main will be correct. It'll advance that.
So I go to that one. Okay. Yeah, but you already have this this branch as well on your side. So
yeah. So yeah. Now the bookmark MRU branch is in the Janaga.net repository. So you can create a pull request from that branch.
Yeah, but I cannot. Here, the open pull request is disabled.
Huh.
This branch is not ahead of the upstream Jinaga bookmark.mru. No commits. Enjoy your day.
Okay. It sounds like it's got the pull request in the opposite direction. Well, that wouldn't be the case either, because main is actually ahead of bookmark MRU.
If I go to main, this branch is up to date, so that's okay. If I go to bookmark MRU.
Yeah, would you like to share the browser window? We can see what's going on there.
So stop this one. The experience was very well, as long as you don't crash.
Mm-hmm.
Which one was it? Yeah, it's this one. Yeah, that's a bit too big, I guess, to... Let's put it half.
Yeah. Nice. That is good. Okay, so yeah, you're on bookmark MRU. And it says it's up to date with... Yeah, of course it's up to date with Janaga.net bookmark.
Contribute. You see, it's disabled here.
Yeah, so I'm confused by the fact that it says that this branch is up to date with Janaga.net bookmark MRU. Okay, so we're looking at your fork. Okay, so just click on the link that says it's forked from Janaga/Janaga.net.
Yep. New window.
Yep. So now you're on the Janaga.net, and
yours?
since you're a contributor, you can create a pull request directly from another branch on Janaga.net. So yeah, go ahead and hit the compare and pull request. There we go.
I'm not following on what.
Yeah. So when you were on your repository, it made an incorrect assumption. It assumed that that bookmark MRU was the default branch. So it wouldn't allow you to create a pull request from bookmark MRU into bookmark MRU.
Okay.
But or at the very least, yeah, it wouldn't allow you to create a pull request from your repository's bookmark MRU to the main repository's bookmark MRU. But yeah, this is the process that I will typically use, because I'm working on a branch within the actual Janaga.net repository and not a fork of it, and then create pull requests within that same repository. Yeah, and this helps to generate the release notes and run all the CI/CD stuff. So
that keeps things nice and clear.
Yep.
And so now, if I go back here to give anything like, no, it doesn't matter. The code is there and the pull request is there, so that's okay. The most important is that the code is there.
Very good.
Okay, but you had a lot to tell, and I was going to take 5 minutes.
Oh, that's quite all right.
Okay.
Okay. So, screen.
So now Michael in accelerated mode.
Yes. we can do this. Okay, there's our pictures. All right. Yeah, the first 5 minutes of this this stream was looking at a blank screen. So maybe I'll throw some pictures on there or something, but okay, but yeah, I was just looking at the how it's using the MRU. Right now it's just checking to see if MRU is coming back as null. So I want to do another check right here. So I'll get that check in there before we create a release. But the most important thing is fixing a couple of defects. So let's start with here with the memory store. So the defect that I saw when I was doing the State of Janaga video, you remember it was not showing something, and then I restarted the application, and then it showed up, and I was like, must be a lingering bug. Yes, it was. So the thing that happened was that when saving, I did not have this lock in the memory store, and so it was doing a fax by reference, add range new fax, so adding these fact pairs to this dictionary. So it was doing that, and then it was also doing the ancestors add. So adding each one of the predecessor facts edges, to basically for each for this fact it's adding each of the predecessor references and their predecessor references and so on up the graph. So the thing about these immutable like immutable dictionary, and this one is also an immutable dictionary, these immutable collections is that when you reference one, you know that it's not going to change, and then you call a method on it, it produces a new structure, and then now you say, oh, okay, that new structure is the true one, so you capture that reference. If you do this without a lock, then you can have two threads come in here at the same time. They both see the old set of fact references, and then they're both trying to add their own individual new facts to it. And then the last one to write back to fact reference is going to clobber the other one.
So you're missing fact references then?
Yeah.
Okay.
Yeah, and the reason that was causing a I mean, that's bad enough already, but the even worse part was that um, one of those threads can get out ahead and um, start adding the ancestors, um, and so then by the time the one clobbers the fact references, but then adds its ancestors, now you've got more things in the ancestor collection than you do in the fact reference collection. And so,
Yeah.
yeah, we were actually, when it happens in that order, that's when you see the exception that showed up. Um,
Last time.
yeah, yeah, yeah. We saw that exception last time, where the fact reference was not in the collection. That's because it found the fact reference inside of ancestors, and then it went back to actually load them in facts by reference, and they weren't there. So these two things got out of sync. They were inconsistent. So I put a lock around it, and so yeah, even though we're working with immutable data structures, we are changing the reference itself. And so that's the thing that really needs to be locked. But doing the lock around the whole thing means that, okay, it's going to operate on those two collections consistently and replace them with consistent pairs of collections. So I went through, did the same kind of analysis for the others, and so for the most part, it's a lock when something can change, but sometimes things are really complicated, and I want to make sure that I've got a consistent set coming into the whole thing. And so I'll lock around a read as well. So execute and match projection is a recursive thing that touches many of these collections. So I wanted to make sure it saw a consistent set of collections. So there is actually probably a faster way to do this. So lock, get the references to all of the collections that you need, and then do the execute and match projection outside of the lock. But I'm not too concerned about that performance at this stage. But then sometimes you, let's get past all of these internal, these private methods, get back to load. So right here, we are going back after the ancestors. And you can see I'm not locking around this thing, but yet I'm reading from a one of the collections. So in this case, I know I'm only reading one of the collections, and I know that since it's immutable, when I get the reference to that collection, I'm not going to be it's not going to be changing underneath me. And then furthermore, I know that all of these references should already be in that collection. So even if something changes and then on the next reference there's a different ancestors collection, the only difference is that it has new stuff that I don't care about.
Yeah.
So so for that, I don't need a lock as long as I mark this as volatile. So .NET guarantees that a reference read is going to be atomic. So you're not going to get half a pointer here and another half a pointer there, and address out into memory. But volatile tells the compiler that that this might change on a different branch or a different thread. So therefore, don't do the optimization tricks where you cache that if you're going to be accessing it multiple times. So
also that might influence performance.
Yes. Yeah, so removing volatile would make would increase performance slightly. In fact, this one is probably a really interesting example of that. So the optimization it would want to do is take that ancestors reference out of the field and stick that on the stack. So right here in the frame. So it's got a cache of that ancestors reference. And so in fact, if I could be confident that that's the optimization it was doing, then I would say I actually want that optimization. I do want this to be the same ancestors reference every time, which means actually I can do the optimization myself. Let me introduce a local for ancestors. Move that up there. Take this back to expression body. There. Make this easier to read. There we go. So this is basically me doing that optimization by hand.
Yeah.
But yeah, since this is volatile, it's not going to further optimize this ancestors reference. It's just going to say, well, it could have changed in the background, so let me really go after it. And now I can cache it, and now for every reference, I know that I'm hitting the same ancestors collection. Yeah. That's actually better. Yeah, I think actually facts by reference is the same idea. Wait a minute, yeah, because that's, yeah, so let's do that too. Okay. So,
And were you able to write some tests which...
Yes. Yeah, so I, let's go down to Janaga test, and inside of, well, let's take a look at the Git history here, see where that was. So yeah, I am on the network. Well, I'm on upload rules. Okay, I'm going to have to move this to the other branch, but I will clean up my Git hobo stuff. Okay, so if I do a Git, I want to do a diff from yeah, let me take a look at network concurrency. So here's okay, I did this on a different machine, so I don't have this. Yeah, let me do a quick stash. And then I can Git checkout network concurrency. Stash pop. Okay, now I've got it on the right branch. And if I do a git log, I can see here's the test. So let me do a git diff dash dash stats. On this guy, and so that was watch from network test. That's what I did. So reload. Control Q, Control T does a code search, and watch from network test. There we go. Okay, so so a few things here. When doing a watch, let's start from an empty upstream. So we've got this fake network, nothing in it. And then I have a single unnamed office. So I put a few things into a feed in my fake network. And then here I've got 2 different feeds. And so before the fix, this test would intermittently fail. Sometimes it would pass, sometimes it would fail. It all depended on the race condition. But now, after the test, the fix, this test passes very consistently.
So that's good news.
Yep. Yep, so I believe that that is fixed. Yeah, so in addition to that sort of thing happening in the memory store, the network manager was having similar issues. So basically I looked at all of the different singleton types. So starting at the Janaga client itself, and then what does it keep around? It keeps around a network manager and a fact manager, and then those keep around an implementation of iNetwork and iStore. So that's where the memory store is, and then iNetwork doesn't have any persistent state, but network manager has some state in order to cache things. And memory store has state for all the reasons that it needs it, because it's a store. But yeah, I found that these immutable dictionaries here, these cache of feeds, those needed some locks. And in this case, there was no optimization that I could find by reading from those things outside of a lock. So everything got a lock, no volatile. Yeah. So if you access the fields inside of a lock, you don't need volatile, because it already assumes that okay, I'm going to enter the lock, and then I'm going to not cache anything in or not use anything that was cached in the frame. I'm just going to go get the things I need, because I'm inside the lock now. So, yeah, things like adding to the active feeds right here now is protected. And then here's another lock around adding to the active feeds. And there's a lock around triggering the current branch, which then comes back around. Yeah. Oh, trigger just starts it off, but yeah, then asynchronously, once the current branch is done, then that comes back around, and it sets the current branch to null. Yeah. So that means doing some other neat things here, like doing an interlocked decrement of the fetch count. So there are other threads that when we say, hey, let's fetch from all the upstream feeds, it says, okay, get all the upstream feeds, start a thread for each one. So they're all racing. So yeah, fetch count is being decremented on each of those different branches or threads. So interlocked decrement will make sure that it it doesn't read it. Also read it here, overwrite the other one. Yeah. Yeah. So went through and found all those things. So yeah, there's remove from feed. Yeah, all the locks in all the right places.
Means it makes the code even more complicated.
Yes, it does.
Yes, but it means in the SQLite store we might also have some of these race conditions.
Yeah, the thing to look for would be just anything that you are caching inside of the store itself. So, like I think you might be caching the
Types.
IDs of type names. Yeah, so those sorts of things.
Uh, which still reminds me that somewhere in the code we had to load them and cache them, which I didn't do yet. I
Oh,
go
that's right.
in
Yeah,
to the database every time.
yeah.
Uh, so that's something I still have to do. And so
Okay.
immediately be careful for race conditions.
Yes. Yeah. Yeah. Go ahead and start out doing it the right way, and then you won't run into the defects after the fact.
It's easier said than done. Foresee everything and do
Mm-hmm.
it immediately the right way.
Yep.
Yeah.
That's true. That's all you have to do.
Yeah. If that would be so easy, in your code there would be no bug.
Yep.
The fact that this bug caught you means that it's not evident at all.
Yeah. Well, I just my tests weren't sufficient to catch the bug, uh,
Mm.
and uh, and I wasn't thinking along those lines yet. It's like, hey, let's make it work. Let's write
Yeah.
tests just enough to describe what the expected behavior should be. But yeah, yep. So that's what you got to do is actually now take a step back, reason through the threading issues, reason through the security issues, reason through, and then analyze the code with that thing in mind. Because you can't keep everything in mind all the time while you're writing the code.
Yeah, because these type of bugs are sometimes very difficult to catch.
Mm-hmm.
I remember one of my softwares, my systems is I had a problem and I think it's a race condition and I never found it in synchronization.
Mm.
So the the solution was to just run a batch every night
Uh-huh.
to go and check whether there was some corruption and to solve the problem.
Ah.
Um, it works for years, but
Mm-hmm.
it's not optimal. Uh, I've been, oh, that's I think about 10 years ago. I've been looking for months for that problem.
Mm.
Never found it. So. And so since 10 years, it's working that way.
Yeah.
Yeah. It's not
Yeah.
a perfect fix.
Yeah. Well, hopefully, we can work out all those bugs at the low level,
Mm.
and then nobody has to suffer through them when they're writing in their application. Um, and I think maybe at some point I'll want to bring in a tool like is it called TPM? Um, Leslie Lamport created a tool to look specifically for concurrency issues in distributed systems software.
Okay.
Yeah, TLA. Yeah, TLA plus. That's what it's called.
I never heard about that tool. So it's like an automatic tester also, or
It's more of a theorem prover. So, as I understand, you take your algorithm that you want to implement, and then you express that algorithm in the TLA plus language, and then it proves that your algorithm um, satisfies the conditions of so there are no race conditions. If you were to execute things in a different order, you would come up with the same answer. But race condition is not just in terms of threads, but also in terms of messages on the network.
okay.
And so I don't believe that it runs directly on C# source code, um, but but I know that the Cosmos team used TLA plus in order to verify their algorithms, and So they might have actually written something to convert from C# into TLA plus, or at the very least, you can just have somebody one-to-one say, okay, this is a TLA description of this source code. So assuming that that they did their job correctly, then TLA plus can find any lingering defects.
It's, made by Leslie Lamport.
Yep.
Okay.
Very
I will
good,
have
sir.
a look at that cache that I still had to build in.
Sounds good.
I'll do it on a separate branch this time.
Yeah, because we already created the PR. So I mean, yeah, you could still add to that that branch, and it'll just add it to the PR. But yeah,
So I make a different one because this is totally different.
yeah,
It's,
it's for a different. Yep.
Okay. Next week, you will be there?
Yes, indeed. Yes, I will.
Okay.
Looking
Me too.
forward to it.
So, okay. Michael, see you next week then.
All right. See you then, Jan.
Okay. See you. Bye-bye.
Bye.